process is right, other than you've got the directions wrong. Common denominator, sounds good, or use a calculator. If they were all in series with each other, that would be fine, but I got a junction between that one, there's a junction there and there, there's a junction between that and those. So you need to add those first, and then do the parallel. So, do that first. You add the series, so you get equivalent for those two, and then you have 4 parallel with whatever equivalent you get for them. There's a junction there, so 4 can't get series with that. Okay.
Check this in between each one individually, like, one of these two, just here, one of these two.
Yeah, and because there's a junction there, it can't be series. And it can't be in parallel yet, because in between those two, you've got a junction this way, and you've got a 2 farad capacitor going the other way, in between the 4 and the 3.
Yes.
No.
Yeah.
Okay.
You're messing up on the simple things here.
I am doing well too.
Yeah, okay, there we go.
But at least I would see your work.
All right. So, again, identifying what's parallel and what's series. 4 is not in parallel with 3, even though I have a junction here and I have a junction here. 4 is not in parallel with 3 because I've got a 2 farad capacitor right there. For things to be in parallel, I can't have anything in between other than junctions. But I do have a 2 in between the 4 and the 3 when I go around the left side. Similarly, 4 is not in parallel with 2 because I got the 3 when I go around the right side. But I do have a series here because I have no junction in between them, so I have to add those first. So 1/2 plus 1/3 is 5/6, and then take the reciprocal. And so this reduces down to 6/5 and 4. Now they're in parallel, and you end up with 5.2 farads. Questions before I make it slightly harder?
Go ahead.
What's the equivalent capacitance? Or how would you approach it?
Since it's not hooked up to a battery, is there any capacitance?
Oh, there is capacitance. But, keep going. What are you thinking, Colin?
I guess it would depend where you hook up the lines for your battery, because if you had it between the 4 and the 5, and the 2 and the 5 would be different if it was in the 2 and the 5.
Okay.
It would depend where you hook the battery to.
It would. Or the probes from your capacity meter,
Yeah.
capacitance meter. So I take my digital multimeter, I put it on capacitance, I take my probes and I put them down where? I'm gonna get a different answer if I put them down here, 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 or here. I basically have 6 choices of where I put down. So I've got across that, there, 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 and there. I have 6 different places I can put this. I've had problems when I've, designed a circuit which tries to target in a specific value, where I just get something like that, without any indication of where the probes go, or hooks up to a battery. And it's difficult to judge. Now, I've given problems like this, and then I said, where to put my probes to get the highest capacitance? Where to put the probes to get the lowest capacitance? So let's do it. So we have 6 choices here. So we've got 2, 3, 4, 5, 2. And just so that we know which one we're talking about, I'm just gonna label this one A, B, C, D, E, and F. So when you have one, just tell me what you get. So pick one, find the equivalent capacitance. If you're sort of stuck on where you're going on this one, it's similar to the one that we had just done. So for instance, for A, the 2, 5, and 4 are in series, because there's no junction in between them. And then whatever you get equivalent for that is in parallel with 3. Oops. Do you have one of them, Dave?
Possibly without calculation,
Oh, okay.
just theoretically,
Which one?
these,
Sid,
these.
B? What'd you get? Or, you said you had one theoretically?
I would, yes, that B would be the lowest.
Or did you write it down, or,
No,
oh, what do you got?
why? Did I say that?
No. Wow, we're out of sync now. You said you had an answer for B?
I thought you said that you could figure it out by calculation or theory, and I looked and I assumed that by theory you would be the lowest.
Oh, so you're saying B is gonna be the lowest or the highest?
I was thinking it was the lowest.
Okay. So you've got your prediction down.
I guess I should do the next set and all instead.
For C and D, are two of them in series? Like, let's see, for C, would the 2 and 3 be in series and the 4 and 5 be in series, and then they're parallel?
Yes,
Okay.
so what'd you get?
Oh, I haven't
Oh,
done that one. I've done A and B.
alright, what'd you get for A?
4.05 farads. And B, I got 3.28.
For C, I have 3.42. And then D, 3.14.
D is 3.14.
1.4. And then E was 4.97. And F was 5.92.
Got some fast fingers over there.
Say it again?
He's got some fast fingers over there. Can't
Oh.
press the buttons that quickly.
Oh, oh, fast fingers. I
Yeah.
said fat fingers. Usually when someone mistypes, thought you were about to challenge them. 3.42 is clearly 3.41. And so it looks like D is actually the lowest, assuming Colin didn't make a mistake. Although my gut was, I was with faith that I thought B would end up being the lowest. So any confirmation on any of these?
So,
I stopped.
Oh,
I guess I just missed the whole, like, pre-lecture on that. So 3 and 5 would be in parallel.
you're on,
Well, like, just in general, if there's, I'm trying to figure out, like, what's,
if 3 and 5, whether they're series or parallel, really does depend upon where you put the probes down.
okay, I'm just trying to understand when, I just lost it.
All right. If I put the probes here and here, so basically situation, oh, the first one, A. The wires, we assume that the wires themselves are ideal, no resistance, they do nothing other than just connect one object to another. So if I put the probes like that, the equivalent in the sort of block form is that I've got probes coming along, and then I get through this junction right here. If I go one way, I get through the 3 farad capacitor. If I go the other way, I hit the 2 farad capacitor. Then I hit the 5 farad capacitor. Then I hit the 4 farad capacitor. And then I go to the other junction. So this would be if I had the probes on 3. That's what it would look like.
Okay, that makes a lot more sense.
Okay.
I got the same for all those.
Okay. So Colin and Enrique are conspiring against everyone else.
I concur, so.
Okay, there's now 3, one more, we've got a majority of people all plotting.
Could you put both of the probes in between like 2 and 3 farads so they all be in series, or would your output just not give you anything?
Oh, if you put it between like that,
Yeah.
you'd get 0 capacitance, or I suspect if you actually did that for real, the multimeter would say overload.
Okay.
Because it assumes that there's a capacitor there, and
So it'll
I can put
just
an
try
infinite
to
amount of
read-
charge on it.
It'll just try to read the short distance instead of going.
Yeah.
Okay.
Yeah. And I've gotten that too. I had one of these, what, 2 years ago, I think it was, where I had a bunch of resistors. And I said, where do you put it to get you have to put it so that there's some resistance. And where do you put it? And several people put it so that, like that, so that there was no resistor in between, and basically short circuited it. Short circuited it. I think I have the right number of syllables. So, yeah, there has to be something in between. All right, now there's one other type problem, the one that Joe mentioned at the very beginning, and I thought, what the heck, let's do one of those. Any questions before, actually, we'll take a break and then do it, just so that I can come up with one with, with an answer. All right, so let's take 5. We'll reconvene, we'll do a problem similar to the one that Joe talked about earlier, and, the rejoicing will just continue. Enrique?
I have a question on one of them. Well, I have a question on that, but like, I wanted to show it right here. So, what did you say these were right here, like these little joints?
Junctions.
Junctions. Like why is there one here but not like, why is this one?
There are junctions there too. I mean, I just did circle.
Okay.
Typically, the circling is to highlight it, not because that's generally the way it's written.
Okay.
So the problem is, given a 2 farad, 3 farad, 4 farad, 6 farad, and 7 farad capacitor, design a circuit such that your final capacitance is between 5.3 farads and 5.8 farads. Sorry, I should have gone around this way the last time. Yeah, it's blinking. So I'm curious about the process. For the 2 who did get it, was it just pure trial and error, or what kind of thought process did you go through?
Mostly trial and error. I just tried to find, numbers that were close to 2-ish so that I could get them, or put them in series so I could get them close to 2, and then take those and add them to parallel so they'd be in the general area.
Okay.
I just tried doing that over and over.
Yeah, and I tried just setting some stuff up randomly, and then I decided to take 1 over the 5.3 and 1 over the 5.8 and created kind of new targets with my fractions instead.
Oh, okay.
And then it was just trial and error from there.
As a general rule with capacitors, if I want to increase capacitance, I do parallel. If I want to reduce capacitance, I do series. A couple other mental tricks here is that if I do a 5 farad in series with a 5 farad, then my combined capacitance is 2.5 farads. So if I've got 6 and 7 combined, that's gonna get me somewhere around 3.5-ish. Somewhere between 3 and 3.5. Now, that would get me somewhere in between 1.5 and 2, and then I've got that 2 stuck out there. It turns out that the combination that works is create a 5 from this, do that in series, and then parallel with that series there, so 6, 7, 4, and then 2, 3. That's one combination that works, and then you had 3 in parallel.
Yeah, they were 4, 7, and 2.
And then that in series with another the parallel structure of the others would
Yeah,
be
6 and 3.
3 and 6. So that also worked. And I gotta remember to not make the target range so small. Because, imagine you're on a test and you could spend an hour working on this one problem. And
On the master set, it was something like 21, I think.
was that the one where I said just get as close as possible to it?
Yeah, it was like 21, and the numbers were 5, 10, 15, 20, 25.
Yeah, so in that case, in terms of grading, if you got the closest, you got full credit. If you were within 1 farad, I think I took off 1 out of 10 points. If you were within 2 farads, 2 out of,
I got you.
and so forth. So for getting close, you got most of the points. And then for people who just slopped together something and came up and were way off, then not as many. Yeah, so anyway, that was a situation where I got tired of the same old questions, then I thought, what could I do differently? Relating back to one of the first questions you asked. All right, so let's go to a more mathematical bent, at least more, I know what you're thinking. You're thinking, this is all great, but we haven't done any calculus yet, so let's do some calculus. I'm doing it for you. Any questions before I look at a spherical capacitor? All right, spherical capacitor. So, in essence, the capacitor, we have two surfaces which are of opposite polarity, same magnitude of charge, just opposite polarity, separated by some distance. So I've got, for this spherical capacitor, I have some conducting surface here with a charge of negative Q on it. And then I've got inside a hollow sphere with a charge of positive Q on it. And I'd like to know the capacitance. They're supposed to be concentric despite the way that I've drawn it. See if I can actually get closer to that. Sadly, that's still closer, but I can't use the parallel plate capacitor formula for this. I have to go back to what